Swayam Prabha. Digital India. Educated India.
Good morning students, welcome to the course of organic farming. So, over the last few classes we have studied what is organic farming, what is the different principles of organic farming and what are the different type of source of organic manures, what are permitted in the organic farming, what is restricted, and also we have gone through the world agricultural scenario, how the annual growth of export potential of the different countries, what is our total India's organic scope and potential, how much we are producing in organically in India and what is our target. So, in this class I will highlighted the role of organic carbon. The organic carbon, its role in the soil health management and carbon sequestration. So, if we see in our system, the soil has a very eminent role. Just I start one quote, our Mahatma Gandhi said, to forget how to dig the earth and to tend the soil is to forget ourselves. So, there is so much importance soil is given to our tradition, our culture, even we go to our Vedas and Upanishads, there is very much tremendous importance given to the soil. Sometimes just like our forefathers, they have made different type of, they have made puja for the soil, and also we have just sometimes we have soil, we are taking the Dharitri Mata. So, we have always given too much importance just like a god or goddess to our soil. Similarly, if we go in a modern agriculture, we have a great proverb, a nation that destroys its soil is destroys itself. So, it is also a proverb by given Franklin D. Roosevelt, who was the former president of the United States. So, in other parts also we have seen the soil has a very great role. Everything is produced within the soil. Here we are there in the earth due to the soil. And do you know how much time needed to produce just a pinch of soil? In the soil surface, to make a 1 centimeter or 1 inch of soil, it takes more than thousand and thousand of years. In the process of weathering of the rocks and minerals, this soil is being produced, but it takes a very long time. But if the faulty agricultural practices is there, we are not maintaining our soil, we make just our soil surface too much open, and there is too much rainfall in a particular day, it may be the wind erosion or the water erosion, that soil is washed away. So, we have to always preserve our soil. This soil will give us not only the food, feed, fodder, fuel, fiber, and also this gives the medicines. So, all the plants and animals are directly or indirectly dependent on the soil. So, it is our responsibility to keep our soil in a fertility condition. We have to improve its condition so that this soil is not for us. We have borrowed this soil from our forefathers, and it is our duty to give this soil to our future generation with improvement, not by the reducing its quality. So, if you see what is organic carbon, just like in our human or animal body, blood has a prominent role to make all our functions available. Similarly, soil organic carbon is so much important for a soil. It is a measurable part of the soil organic matter. Soil organic matter is different type of things. When we are applying any crop residue, we are giving any cow dung, urine or any plant debris, these all are called organic matter. And within this, the core part is the soil organic carbon. If we see, the carbon is a very important part. In our every living body is made of carbon by 40 to 45%. If you may, and this carbon has a tremendous role, is binding with the other nutrients, so enhances the different type of soil properties, maybe physical, chemical and biological, which I will cover in later part of my lecture. So, if we see, there is the two terms I have just mentioned, one is the organic material and one is the organic matter. So, what is the difference between these two terms? If we see the organic materials is anything that was alive. It may be plant body, it may be animal body, that was one time there was a living things, but after the dead we got the animal excreta, animal body, animal also excreta, we are getting the urine, cow dung, swine, similarly the pig manure, poultry manure. Similarly, also we are getting different type of organic materials from the plant products. We are using the rice, we are using the wheat, but whatever is the rice straw or the wheat straw, maize straw, vegetable waste, these all are called organic materials which certain time they are alive, but now we have applied in the soil. So, but it is not directly organic matter. So, these have to be go through the process of decomposition. When it go for the process of decomposition, then only it's become the organic matter. So, when you give some organic materials, maybe 500 kilo of crop residue in the soil, after some time it will not be 500 kilo. It will decompose by different type of soil pathogens and it will change into the organic matter. And this organic matter is now stable in the soil. It has been decomposed until it is resistant to the further decomposition. So, if we see the what is the soil organic matter consist of, generally soil organic carbon matters three main things: carbon, hydrogen and oxygen. Just like our human body, that is the majority also these three things. Any living plant in the planet is primarily made of carbon, hydrogen and oxygen, and we have some small amount of other elements, maybe nitrogen, phosphorus, sulfur, potassium, calcium, magnesium in this organic wastes. So, now I want to term, so what is the difference between soil organic carbon and what is the soil organic matter? So, soil organic carbon, a soil organic matter, when the organic materials is go in the process of decompositions, it becomes soil organic matter and it is now stable. But 100% of that soil organic matter is not the carbon, because in just now I am tell, apart from the carbon we have also other parts. What is this? We have the nitrogen, we have hydrogen, we have oxygen and other minerals. So, organic carbon is referred to the carbon component, and we cannot measure how much soil organic matter present in the soil, but we can measure the soil organic carbon, and there is a standard ratio between the soil organic carbon and the soil organic matter. So, if in our laboratory condition, if we take the soil and if we can measure the soil organic carbon by multiplying a predetermined factor, we can work out how much soil organic matter in our field. So, many times we are think of the organic matter is the plant and animal residue incorporated to the soil. Thus, actually we are giving the organic materials, not the organic matter. This organic material process through the decomposition go to the organic matter, and within this organic matter a certain part is the organic carbon. So, how is playing his different role? Soil organic carbon, everyone we know nitrogen. When we are going more of food for the too much population, nowadays our population is about 700 billion. So, we have to feed this world. So, for that different type of high yielding varieties has came, and we are growing high yielding crops, hybrids. So, we need lot of nutrients, majority of nitrogen. Nitrogen we are applying as a fertilizer in the source of urea, otherwise we can also give in the source of DAP. So, if we see that this carbon and nitrogen, they have some role and they are always binding together, and there is a fixed ratio of the carbon and the nitrogen. So, for example, a CN ratio mean 10:1. In mean, if there is 1 parts of nitrogen is there in the soil, definitely there will be 10 parts of carbon. This ratio is fixed. After the decomposition in the soil, if the ratio we have take 10:1, so similarly, if we conserve more and more carbon in the soil, so it will also help to bind the nitrogen. So, how can we enhance the nitrogen availability in the soil? We have to enhance the availability of the organic carbon in the soil. Similarly, the microbes, there are lots of soil microbes and they have played a eminent role in the decomposition process. I have already told, whenever we are applying too much of organic waste or materials in the soil, they gone through the process of decomposition. So, what we do, there is some carbon materials we applied in the soil. Suppose you have given some rice straw. The rice straw, immediately that nitrogen is not available to the plants. When we give this into the soil, it will go the decomposition. Whenever there is too much carbon, the microorganisms will come, their population will increase. They will take the carbon as a source of energy, but all the carbon they cannot remain in their body. Some part of that carbon will remain in the body of the microorganisms, and remaining part again go back to the atmosphere. So, what is the thing? Suppose 10 kilo carbonaceous materials we are putting in the soil, it does not mean all the 10 kilo will be stable in the soil. Maybe 1 kilo may be added in the soil and 9 kilo again going back to the atmosphere in the form of carbon dioxide. So, in the soil, if we see 24:1, is rules the soil, there is a formula. So what happened? This is a just mathematical calculation I want to know. Just if a higher foodstuff, suppose you are giving, this is wheat straw, this is wheat straw, and it has a very high carbon is to nitrogen ratio, it can more than 80:1. So nitrogen is very less, carbon is very high, but when it will go into the soil, it want to make into the soil in a stable form, it is to come is to 24:1. So here what happened, more carbon is there, nitrogen is less. So what the microbe will do? Microbe body has a fixed nitrogen content, I have 10 CH2 and 8:1. So they will take additional nitrogen, they will search for the nitrogen in the soil where we get nitrogen, and wherever they get the nitrogen from the available nitrogen they will absorb. In the process they will decompose the wheat straw, but immediately what happened after the application of this wheat straw in the field, the nitrogen availability will be low, because most of the available nitrogen is taken by the microbes. So there may be some temporarily less availability of available nitrogen for the plant growth. Certain after the time when these microbes will decompose or die, that nitrogen again go back to the soil, but immediately after the application the crops suffer maybe for the nitrogen deficiency. So we cannot apply this type of organic straw directly into the field, it is always better first decompose somewhat purpose and after that we should use in the field. Similarly, now we think the other phenomenon, where we have added some stover, maybe straw, that is fetch. Fetch is just one type of legume crop, and if we show these debris, what happened? Their CH2N ratio is 11:1. It means carbon is less, nitrogen is more. But in our soil, I have already told the microbes maintain 24:1 in the soil. So what will happen? This is a very good thing you have to want to notice. Here nitrogen is available, carbon is less. So what's the microbe will do? Microbe will search the additional carbon, and whatever the any plant residue is there, maybe rice residue, wheat residue, other type of crop residue is there, they will take as a feeding materials and they will decompose. So our decomposition process will be faster. When we are giving rice straw or wheat straw, due to the high CN ratio, process is slow, they will take the nitrogen from the soil. So there will be some unavailability of the nitrogen or lesser availability, but in case of legume residue when you are incorporated in the soil, what will happen? They release the extra nitrogen in the soil. So available nitrogen in the soil will be good, so that crop will be planted. That's why I want to tell these legumes has a very important role in our system for maintaining the nitrogen availability to the plants. This is CN ratio is there, this is some region. So that's why there is two terms. One is the immobilization and one is the mineralization. Mineralization is the process by which some organic matter, when parts of the decomposition, the nitrogen is being released. So this nitrogen can be taken by the plant for their plant growth and development as a form of the nitrate. So this is called the mineralization. The opposite part is the immobilization. It means whatever the available nitrogen is available in the soil, that plant cannot take, because we are adding too much crop residue which is very high CN ratio, that nutrients nitrogen is taken by the microbes, and so for certain part of time it becomes immobilized, means it is not directly available to the plants. So whenever we applying some crop residue in the field, we have to take in our mind whether immobilization will occur or the mineralization occur, but the ratio is 20:30:1. Both processes will simultaneously, and that is very much optimum for plant growth. So carbon to nitrogen ratio of crop residue and materials. So there are different type of CH2N ratio in the soil, and we have worked out what is the ratio. If I see these three straw is very high, rice straw, wheat straw and oat straw. So it is our basic rule, whenever we applying this type of straw, we should eitherly partially decomposed we should apply, otherwise we can add some type of legume straw or cow manure or other form of manure along with them in the soil, otherwise there may be immobilization and nutrient nitrogen deficiency for certain part of time. While you see our legume crops, they are very good, their CH2N ratio is very much less. So they are always, we are advocating to use this type of legume in the soil, and soil microbe always has a fixed in their body 8:1. So if you show, whenever we are applying these materials, which have a very high C in H to ratio, our decomposition rate is slower. So, we have to take more time for the decomposition. However, when we are giving this type of legume residue in the soil, our decomposition rate is faster. So, it will be easily available to the plant within less time as compared to our previous ones. So, how the decomposition process, how the soil is organic matter is being decomposed in the soil. When we are plant residue reach on the soil, the decomposition occur. But decomposition is a biological process. Biological process means there is a need of different type of microorganisms, maybe some bacteria, maybe some fungus or protozoans, animals. So, they generally physically break down the organic matter and they have transformed these complex organic molecules of dead materials into simply organic and inorganic molecules. So, there are three major factors is determined by the process of the decomposition. One is the soil organisms. If the soil organisms they are faster, if their population is very high, then definitely our process will be high. And soil organic carbon plays a very prominent role to determine the number as well as the variety of the soil microbes present in the soil. Similarly, the physical environment, whether there is soil moisture or there is less soil moisture, whether too much dryness is there or not, whether the temperature is too high or temperature is too low. Suppose if the temperature is minus, it is frozen, so microbial activity their speed is less. So, the decomposition will take time, but the temperature is high. Similarly, if we see in our West Bengal condition, Bihar, otherwise in the UP, Punjab, Haryana condition, temperature is very high. So, decomposition rate is very high and most of the carbon we are added in the soil is going back to the atmosphere. If the temperature is low in temperate soil, so the process is slow, so that more carbon, stable carbon is being conserved in the soil and the rate of carbon sequestration is relatively higher. And also the quality of organic matter. I have already told you which type of organic matter, either it is wheat straw, oat straw or the legume straw. So, microorganisms involves in the decomposition. Different type of microorganisms take part. One is the bacteria maybe, and different in the early stage of decomposition some microbes worked. In the later part of the decomposition some of the microbes may be work. Suppose in the early part of decomposition we are taking the help of Bacillus, Streptococcus, while in case of the later part followed by Salmonella occur. So, when their population is well maintained in the soil, our decomposition pace will be high. And if there is suppose too much water stagnation is there, so there may be temporarily the population of these bacteria may be low. So, when the population will be low, the decomposition rate will be low. That is why we have to always maintain a very good quality soil health. If the soil microbiota is all this population is too much affected by continuous use of only inorganic fertilizer without addition any organic manure or legume crops, or soil fertility decrease due to the less abundance of these types of bacteria. So, this is the process of decomposition of the organic matter. Suppose one leaf has come to the tree, some part of this leaf as insect by the insect and other animals and nutrient energy, some nutrient leach into the soil, go back to the soil, some in the decomposition process some of the nutrient mainly carbon dioxide decomposition CO2 again get back to the atmosphere. So, further it is being decomposed by the different type of earthworms, bacteria and fungi, and ultimately our soil become organic rich. So, always we have tried to balance different type of organic materials, organic residues we have to promote, and in organic farming they have a tremendous role. This all indirectly or directly lead to the addition of soil organic carbon. So, this is the soil and climate change. Nowadays, we are knowing climate change is happening in a very high alarming stage. Previously, temperature have been increased about 0.8 to 1 degree in the last century. The carbon dioxide concentration has increased from 280 ppm to more than 420 ppm. So, due to this temperature, there are lots of extra calamities also happened. Sometimes we are getting too much rain, sometimes we are getting not rain. Suppose we are growing a particular crop and there is in the Kharif season itself, there is we are getting total amount of rainfall is good, but for a 15 days period we are getting not a single drop of rain. So, if the soil quality is bad, if the soil organic carbon is less, it means it will conserve less water in the soil. So, that soil cannot support the plant growth by provide sufficient quantity of water over period of time. But if the soil health is good, soil organic carbon is very good amount, so it means water holding capacity of the soil will be increased and that will supply water to the plants, so that in climatic change Why? Because we don't know, probably tomorrow there will be too much rain or less rain, and climate change will be intensified over the region, because every time we are going, everyone want to purchase car, everyone we need energy. And so when in the climate change scenario, this soil organic carbon has a very prominent role, and organic farming have some good potential to mitigate this global warming potential. So if we see, there is the climate stress in Indian agriculture. This is very common. Our 70% land is the drought prone. So actually we are getting less rain. Sometimes we have to give the irrigation. 20% we are getting very much the flood prone. So there is too much rainfall in a 1 or 2 days. Even in the parts of Mumbai, this year parts of the Delhi, we have seen in a single day too much rain, all area is flooded. And also there are certain parts of cyclones. So frost is very much common, frequent heat is common. So in this condition, soil organic carbon has a very good role, and we have just worked out the different type of climatic map of the India, and we have to think for particular region which way we have to grow, which of the soil fertility building measures, soil conditioner we have to use, so that our agriculture should be climate resilient, so that tomorrow there is some climatic vulnerability or food grain production should not down drastically, so that we cannot able to feed our population. So climate change affects the crop production in the different way. If you see, our temperature is increased over the 100 years, temperature increase. Similarly, when the temperature is increased, our weather hazards is coming, either flood, maybe drought, either maybe different type of cyclone. Similarly, we are going to see the sea level rise. A 1 meter sea level rise can occur in the near future, and which will inundate a vast area of not only the world cities, also in the India. And the coastal cities may be like Mumbai, maybe like Visakhapatnam, and other parts, they are in very much danger. So always we have to take care of this global warming potential. We have to try to mitigate the carbon dioxide and other greenhouse gas emission from the different type of industrial and other man-made anthropogenic activities. And ultimately we are getting also too much droughts. So organic farming and soil organic carbon has some answer to address these issues. If we see, if the increased greenhouse gas temperature it will increase the temperature. So greater evapotranspiration will be had, most of the water will be drained out, there will be soil water deficit. When the soil water deficit, our crop will be reduced, and there will be more mineralization, more salinization, because you are taking underground water, suppose in the parts of different parts of mainly the plain land, Punjab, Haryana, Western Uttar Pradesh, to grow crop we are giving 10-15 irrigation, and ultimately we are making salinized in our surface soil. So ultimately that all will affected our the soil health. So the soil health is paramount importance. We have to always take care of soil health. So we should always promote that type of agricultural activities which not only reducing the quality of the soil. So also I am telling, when the climate change is occurring, when the temperature is increasing, there is also chance of secondary like insect, pest, disease attack will be enhanced. So we need more water, we need more nutrient, we need more energy. So there are different type of agronomic and breeding practices we have to follow, and we have to always maintain our soil in a very good condition, so that we cannot sacrifice our crop yield. We have to produce enough food to feed our population. So always this climate change effect on the crop yield we have to taken care of, and we have to make that type of agriculture, that type of soil fertility build up, so that our agriculture should be climate resilient, it will be less affected by the climate change. If you see the nutrient use efficiency in India, suppose we are giving lots of nutrients in the soil. Every year we are giving 1000 and 1000 tons, and if we see particularly, suppose we are applying 100 kilo of nitrogen in a agricultural field. So do you think all the 100 kilo of nitrogen, whatever we are applying, is directly getting by the plants? The answer is absolutely no. Out of the 100 kilo of nitrogen, only 30 to 50 kilo nitrogen is taken by the plants. That means the nutrient use efficiency of nitrogen is only 30 to 50%. Phosphorus, it is again low. Whatever the phosphorus we are applied, suppose 100 kilo phosphorus we are applied in the soil, about 80 to 85 kilo phosphorus is fixed in the soil. It may be in the acidic soil, it may be fixed with the minerals like aluminum and iron, while in case of calcareous soil, otherwise in high pH soil, it may be fixed with calcium and magnesium. So, only 15 to 20% of the given phosphorus is available for the plant. Similarly, if we guess for the micronutrient, the nitrogen efficiency is very low, 2, 5%, 1%. So, always, and soil organic carbon is a very good role. Most of the nutrient when we are applying in the soil, it's go by the denitrification process, may be volatilized, may be leaching, and I have already told previous slides, carbon and nitrogen has a very good role. If the carbon will be high, so they can concentrate, they can keep the nitrogen intact. So, for enhancing the nitrogen use efficiency and to keep the nitrogen in the field, we have to maintain the soil quality, and for that soil organic carbon content we have to maintain. Then automatically it will try to absorb these nutrients and they will not allow too much to loss from our ecosystem. This is the soil management for climate change mitigation. We have know that is the sustainable intensification is needed, improving the nitrogen fertilizer management so that nitrogen loss will be less, and also the different type of improved management. The demand for opportunities different, that one is the sequestration carbon. What is the carbon sequestration? It's mean how we can conserve the carbon in the soil so that the carbon dioxide emission from the soil will be less, our atmospheric carbon dioxide concentration will be less, and so that the ill effect of the climate change will not be too much as we are projecting. So, this is the importance of soil organic matter in a healthy soil. They play in different roles, soil organic matter plays in a different role. One is the physical. What is the physical soil structure? Physical mean what is the condition of the soil. When we apply some soil organic matter, so this soil organic carbon helps the improve the physical characteristics of the soil. First, the water infiltration rate. So, the water will be rainfall, more water will be entry into the soil. Suppose this is our soil surface and this is the rain is coming. So, more water will go into the soil. So, it means our surface runoff will be less and more of the water entry, the water recharge, groundwater recharge will be there. Similarly, water holding capacity. If the soil can keep more quality of water in within the soil, it can provide some time of water for the when there is no water, when there is no rainfall. So, water holding capacity is very much important for a optimum plant growth and productivity. And also they are giving plant root and soil organisms better living condition. They are reducing the temperature, they are giving some atmospheric condition, and they also reduce the soil erosion. So, if we see in the different types of the soil physical activities, when the soil physical structure will be good, our surface runoff will be less. So, there will be when there is too much rainfall on a particular day, our soil will not be easily detached from the surface. So, soil loss will be less, soil erosion will be less, and we know a huge area of India under different type of soil erosion, maybe in water erosion and weed erosion. Similarly, the chemical. Chemical mean whatever the different type of nutrients we are providing by the soil organic matter. So, it not only give the different type of nutrient for the plants, maybe nitrogen, phosphorus, potassium and secondary and micronutrients, but it also help to conserve them. When the organic matter is a very good surface area, so they can absorb different type of nutrients in its outer side, and that will help to retain these nutrients within the soil. And ultimately what happened, when we grow some plants where lots of organic matter is there, lots of soil organic carbon is there, so they get all these available nutrients. So, probably definitely our crop growth and productivity is enhanced. This third part is the biological activity. I have already told there is too much soil biota present within the soil. There are different type of biological biota. It's maybe protozoans, maybe earthworms, maybe bacteria, maybe some fungus, maybe some rodents, earthworms. So, this has some definite role. If we cannot apply, we are not applying organic manure, their population is decreasing, their diversity is decreasing, but all these soil biological organisms play a very prominent role. Some was maybe nitrogen fixation, some was help in the solubilization of the phosphorus, some will help in the solubilization of the potassium. So, if this biological process, it's in the soil organic carbon gives the energy for the carbon and nutrient to the soil organism, and this capturing the carbon in the form of different type of carbon sequestration process, when the soil organic carbon is more in the soil, so the biological diversity of the soil is enhanced, and ultimately it will maintain a very good balance, and ultimately our crop growth and yield will be enhanced. So, role of organic carbon in nutrient supply. So, it improves the physical condition of the soil. I have already told different type of physical structure in the soil by maybe the aggregate stability and also the soil surface area, it has changed. So, ultimately they have indirectly or directly also helps in the different type of ways. Suppose it also increasing the water holding capacity of the soil. So, water holding capacity I have already discussed has a very tremendous role for agriculture in case of rain fed agriculture, and in India majority of area our rain fed condition where the farmers have not their irrigation capacity. So, when there is no irrigation, whatever the water stored within the soil and whatever the rain water, this only two the determinative factor of a crop yield. It also improves the aeration and infiltration rate. It reduces the loss of soil. I have already discussed how it will bind the soil, it will cover the soil, and definitely the water runoff will be less, the water erosion will be minimized, also the wind erosion. It regulates the soil temperature. The soil temperature I have already telling you that it is regulate. It means when the temperature is very high, it will give as a buffer. The sunlight directly not coming to the soil. If suppose we are giving some cover crop or crop residue or a mulch, so sunlight direct not really enter into the soil, so temperature will be reduced, so that our soil condition, soil different process will function properly. Similarly, in case of winter, when there is too much low temperature, if there is soil surface cover or the soil organic carbon is high, it will maintain the temperature or enhance the temperature. That is why we have written that is it regulates the soil temperature. Similarly, you have also important source of different type of nitrogen. It have also giving different type nutrients like nitrogen, phosphorus, sulfur and others. And the buffering nature of the organic matter, buffer, this is a very much important things. Sometimes we are also giving, so suppose soil pH is very much less in acidic soil, but we are applying continuously organic carbon, organic manure over the years 10 ton, 15 ton per hectare. See, it also helps the enhancing the soil pH and makes the soil towards the neutrality. Sometimes also if there is soil too much alkalinity is there, soil pH is high, and we are also applying the organic matter every year, so it was somewhat reduce the pH. So, it always maintain a very good buffer zone, and in this buffer zone, in this buffer condition, most of our soil available nutrients become available for plant. And if you see, this is the different type of nutrients, this is the clay humus contracts, and in this picture how all the nutrient how they are absorbed in the clay humus compass, and this soil carbon has a very prominent role due to their high physical improvement of the structure of the soil and also their surface area, and most of the nutrients, it may be potassium, it may be different types sodium, magnesium, calcium, they have definite role and they will help the absorb of our nutrients within the soil, reducing the leaching and other losses. This is the soil quality, and this is the soil quality index. Some index has been worked out over the years. So, how to define whether our soil quality is good or soil quality is bad? If the index is positive side, then it is good. Whether is the soil quality index is the negative side, it is regarded as the bad. And if we see, we have done some Mandal in 2009, they have just published different type of things, when we have seen, if you see, in case of 1, that is control, in case of 2, we are giving only NPK, and in case of 4, we are giving NPK plus paddy straw. In all these things, our soil qualities become negative. But when the soil qualities become positive, that is 3, mean we are giving NPK plus FYM, and also for the 5, that is NPK plus the green manure. So, if you can see in this condition, we have a very good role of the FYM and the green manure. When we apply this type of carbonaceous materials in the soil years after year, our soil quality is being good. Similarly, so there is always a question, how we will balance our soil organic carbon? One process is the hoarding. We are giving different type of cover crops, we are giving the residue, we are giving cow dung, we are giving different type of compost, crop residue, kitchen waste, municipal waste, these all are hoarding. But whatever I have told, whenever we apply this type of organic materials in the soil, it is not necessary that 100% will be carbon will be absorbed in the soil. Majority will go back to the again atmosphere by the process of decomposition. So, this is not called as the carbon sequestration. If you are applying 100 kilo carbon, it does not mean your soil carbon will be enhanced by 100 kilo. It may be enhanced by 5 or 7 kilo over the years, and 90 to 95 kilo again back to the atmosphere. So, always we have to try and maintain a balance, how much organic carbon we are applying in the soil, and out of this carbon how much again going back to the atmosphere in the process of decomposition. So, if we see the nature, significance and typical quantities of some selected organic matter. So, if we show different type of organic carbon is there, and total organic carbon may be 7 to 60 carbon per hectare. There are different type of organic carbon of this particular organic carbon, and this is different type of chemistry is there, and different type of estimation techniques in the laboratory is there, because every carbon has a different fraction. Some are very easily labile, some are easily available, some may be stable. So, we have to work out different type of carbon fractionation in the soil over the time, and how the carbon dynamics is being affected by the different type of processes, and also the microbial biomass. Whatever the microbes, soil microbes, when they take the carbon as a source of energy, so they also certain parts of carbon within them. So, if in a certain particular, if we can estimate the soil microbial biomass carbon, that is called SMBC, it means soil microbial biomass carbon. If the soil microbial carbon is very high, it means soil is a good microbial population is there, it means soil biological activity will be higher, and definitely this carbon is very easily available by the plants. Similarly, this is the schematic diagram showing the relationship between various organic matter fractions. So, we are applying the crop residue again is going back to the particular organic matter, some will be root over turnover, some will again going back to the soluble organic matter. So, this soluble organic matter in the process, it is mineralization organic matter which can be taken by the plant. Similarly, some of organic carbon is taken by the microbial biomass, soil microbes, that again will in the process of the mineralization plants can get in, and also there is some materials which we can extract. So, this type of different carbon fractionation within the soil has a prominent role in our system. So, whenever we have to try maintain a very good quality balance of these different of soil organic carbon pools, and this is the different process which affect the soil organic carbon dynamics. When we apply the carbon added, some one is the oxidation, mean carbon is going back to the carbon dioxide. Some is the humification. So, it ultimately in case of too much rainfall, the water is going along the water, it also carries too much the soil particle. So, ultimately this carbon is being lost along with the soil. Some also doing by the leaching process, and also it go to the aquatic system in the water bodies. So, there are a different type of losses mechanism of the carbon, and it is our primary role to reduce these losses of carbon from the soil. We have to enhance the soil organic carbon content, we have to carbon sequester, so that our soil quality will be maintained. This is just one experiment has been done in 1996 back, but it is a very classical example I can show you. One is the conventional system. Conventional system matlab only we are giving nitrogen, phosphorus, potassium, this type of inorganic fertilizer. And what is the other system? System is the organic matter retention. So, I will show over the in long term how the soil organic matter changing the soil pH. So, anyone can ask what is the different role of pH. Most of the soil organic, most of the available nutrients in the soil are available when the pH is near neutral. If the pH is very less than 5, that some nutrients are not available. If the pH is very high, more than 8, some nutrients are not available. So, always we try to keep some good soil pH in the neutral range, maybe within 6 to 7. So, if you see, if we in the different soil depth they has done the experiment, if the conventional system soil pH is 4.5, however, with the organic matter residue in the plot, we are getting near about 6. Similarly, in the another depth where we are getting about little bit 5.6, but in case of it is will be 5.8. So, soil pH is enhanced by the addition of organic matter. When the soil pH is enhanced, automatically different type of nutrients availability to the plant will be good. When the nutrients will be available by the plant can extract them easily, and plant could perform better growth and productivity. Now, the comes the soil or carbon sequestration. What is the definition of the carbon sequestration? The one thing we have to very much sure when we are define the soil organic carbon sequestration, it should be long term storage of carbon. It's mean already I have told I am applying 100 kilo of carbon and only 5 kilo is being stable, that will fix in the soil and that will maintain for some time, and rest of the carbon is not being stable in the soil, that will go back to the atmosphere in the form of carbon dioxide. So, the whole amount of carbon is being not sequestered. So, sequestration matlab sequestration mean that carbon should keep in the soil, that have to be maintained in the soil for sufficiently long period, maybe 50 years, 100 years or more. then only we can tell that carbon has been sequestered. Then only we can tell in the certain process we are taking the carbon dioxide back from the atmosphere and putting within the soil, and if this soil is carbon is maintaining sufficiently long in the soil, we can tell this much carbon has been sequestered from the atmosphere to our soil. So, we are giving the mitigation of the soil different type of climatic gases, mainly the greenhouse gases of carbon dioxide. By this agricultural process, we can reduce the concentration of the CO2 and the bad effect of the climate change. If we see the definition of the Olsen, it is the process of transferring carbon dioxide from the atmosphere into the soil of a land through plants, plant residues and other organic solids which are stored or retained unit as a part of the soil organic matter. If you see, although oceans store most of the earth's carbon, soil contain approximately 75% of the carbon put on land. So, this soil, our different agricultural activity, we have a very huge opportunity for the carbon sequestration. This is the balance already I have told. Now, if I see what is the different process of the farming carbon, how we can, previously we are farming of agriculture, maybe farming of crops. Now, the new term has come, that is farming carbon. Matlab how we can conserve the carbon in the soil, how we can reduce our atmospheric CO2 concentration, how you do the carbon sequestration. An organic farming has a very good role for this carbon sequestration potential. In organic farming, we are using crop residues. We are using different lots of crop residues, jungle biomass, maybe kitchen waste, maybe rice straw, maybe maize straw, everything we are using. So, when we are using this crop residue, we are applying carbon to the soil. Similarly, we are always follow suitable crop rotation. In organic farming, we are not telling every time you grow single crop like rice and wheat, because I have already discussed if I apply the rice and wheat straw and other straw, what is the fate? Most of the cases there may be immobilization, but in case of we are applying fetch or other legume straw, the nitrogen is being mineralized to the plants. So, we have crop rotation in the organic farming. Similarly, crop diversification, we are not only one crop, we are growing different type of crops over the year in maybe cropping system mode, maybe intercropping, maybe mixed cropping. Similarly, it also moderate the temperature and moisture regime, because we are always promote the cover crop residue. We are also giving the cropping with high residues carbon. So, all these activities of the organic farming has a very good role for the farming option. That is, we can do farming carbon, we can conserve the carbon within our soil. Now, how carbon is sequestered? What is the process by which carbon is being stored in the soil? We know in the process of photosynthesis, plant assimilate carbon and return some of it to the atmosphere through respiration. This is the plant body. Carbon dioxide is coming in the process of photosynthesis, and whatever the carbon is coming in, because I have already told in plant part also 45% around is the carbon. So, but whatever the carbon dioxide is being photosynthesis, all is not going back to the soil. Some part is again going back to the atmosphere. So, this is the CO2 respiration, and whatever the organic matter is coming that is in the soil, that is I call the free organic carbon. And this free organic carbon is not, there is a lot of process in the soil they have to go past. Some they may be soil organic carbon in aggregate, and that should be protected by the organic carbon, that should not be easily attacked by the microbes. So, when that part of carbon which enter into the soil and that little bit resistant or recalcitrant which cannot be used by the microbes for further decomposition, that carbon can be stored for longer period of time, and that carbon only we can tell the carbon sequestration. Agroforestry is a very prominent example of the carbon sequestration, because whenever I am telling we are using the crop residue, most of the crop residue we are applying in the soil surface, and more than 98 or 99% of that crop residue carbon is decomposed by the soil microbes and again going back to the atmosphere. So, that carbon sequestration potential is comparatively low, but in case of different type of agroforestry, one agriculture along with the forestry trees, this plant has very big trunk and big canopy, and their roots is very deeply entombed in the soil. So, all the carbon which is going accumulated in the deeper soil layer, that is not easily decomposed by the microbes. Most of the soil microbe is present in the surface layer. The soil microbes concentration in the lower part of the soil is very less. Similarly, alt our temperature or climatic activity change in the surface system. So, whatever the carbon we can store in the deep layer, it is recalcitrant or it can be stable. So, by promotion of different type of forest trees, different type of plant trees, mainly the multipurpose trees or perennial trees, along with the agriculture, there is a scope of organic carbon sequestration. And this is the different plants, you can mow Tephrosia candida, large cardamom base, Tephrosia based. So, there are different type of models of this agroforestry system for carbon sequestration. If we see the carbon stock in our agricultural soil, there is a potential to 1.2 billion ton carbon per year. So, this is a huge amount. If we using lots of our existing agricultural technology, scientific agricultural technology, our agriculture can mitigate lot of carbon dioxide which is already present in the atmosphere. So, we can reduce the carbon dioxide concentration in the soil atmosphere and the ill effect of climate change. And if we see, we can request at least 10% of the current annual emission, because every day our greenhouse gas emission is going to be increased. People needs energy, people need industries, people need cars and other things. So, carbon dioxide emission is increasing, and even we can just reduce or sequester 10% of that carbon dioxide emission, that will be very huge role. Even we can reduce the carbon dioxide concentration in the atmosphere by 10 or 15 ppm, that effect will be very good. And this is the different type of pictures we have shown. What is the carbon sequestration potential? So, we have done different type of activities over the year, and if we see, one is the CSP, this is the carbon sequestration potential, and this is, you will see, this is the higher carbon sequestration potential is given for different type of activities, that is FYM. After that, what we are getting? Green manure. So, when we are applying nothing, this crop, our carbon sequestration potential is very less. But when we are applying FYM in the soil, we are applying the green manure crops or other things, so our carbon sequestration potential is very high. So, these type of some activities by which we can enhance the process of the carbon sequestration. The role of soil carbon in different ecosystem. Our approximately 8.7 gigaton carbon per year being emitted in the atmosphere from anthropogenic sources, and it has been reported that agriculture have lost 30 to 35% original soil organic carbon stocks. It means whatever the soil organic carbon concentration in the soil, maybe 30, maybe 100 years back, nowadays we have not that sufficient amount of the soil organic carbon. Over the last 100 or 500 or 1000 years, the continuous agricultural process, our soil organic carbon has been decreased. So, this is our now role, how we can back again enhance the soil organic carbon, and how can we change our soil agricultural system, how can we manage the carbon in the soil. So, whatever the loss of the soil organic carbon has been occurred over the years, some part of that carbon, if we want to back into the soil, and if we succeed, that will be very high activity, and that will help to conserve our soil for our future generation. This is the benefit of the soil carbon sequestration. I have already told that it improves the soil structure, less erosion, improve the fertility, biodiversity, healthier ecology and other agricultural performance. And this we have to always think about these things. So, soil organic carbon plays a very prominent role, and organic farming by doing different type of crop rotation, cover crops, green manure and organic manure addition help to conserve the organic carbon in the soil. This is the composition of the carbon stock. How can we calculate? Suppose in a particular field, in a particular area, we have want to know what is the soil organic carbon concentration is there and how much it is present now. If you see, the depth is 0 to 10 centimeter, and it means the soil depth is 10 centimeter. What is the bulk density? It is 1.2 ton per meter cube. Soil organic carbon in 1700 years, it means more than 300 years ago, it is 2.5%. So, how can we calculate what is the soil organic carbon? This is very simple. You have to multiply by the area with the depth, with the bulk density, with the soil organic carbon. So, in this case of area, we have no, this is 10 to the power 4 meter square per hectare area of a hectare. What is the depth? 10 centimeter, it is matter of 10 to the power 1 meter. What is the soil organic carbon then bulk density? That is 1.2 ton per hectare, and what will be our condition of the soil organic carbon? 2.5%. So, if we multiply these things, area with depth into bulk density and soil carbon, it is coming 30 ton per hectare, you see. So, in case of our pre-industrial level, when agriculture was very traditional, our soil organic carbon is 30 ton per hectare. Now, it is only 12 ton per hectare. So, 18 ton of soil organic carbon is being lost over the 300 years. So, if we want to improve our soil conditions, soil fertility, soil quality, we need to enhance our soil organic carbon to some extent. And there are different type of process which conducive the soil organic carbon strategy. It is maybe aggregation, it may be the process of humification, translocation into subsoil, formation of the secondary carbonates, burial of the soil organic carbon laden sediments, and plantation of deep rooted plants. I have already told the role of the agroforestry in the carbon sequestration in this era. So, we have done some experiment over the world over, and we have seen what is the soil fertility management on soil organic carbon in the long term experiment. Particularly if we are applying some carbon and we cannot just think within 1 or 2 years our soil organic carbon will be enhanced significantly, so that the lots of changes will be occurred. There are different type of long term experiments, some experiment may be 10 years, some year may be 25 years. So, what is the result? And where we have seen different type of location, in one set of experiment we are giving only NPK, only the inorganic fertilizer. In the second part of experiment we are giving NPK along with the FOM, and you see what is the our soil organic carbon content, where we are giving in case of different types of or NPK, the control was 4.8, that in the initial level the organic carbon content is 4.8. When we are giving NPK it is 5.9, but in case of FOM it is 8.4. So, soil organic carbon enhanced significantly from 4.8 to 8.4. Similarly, in case of suppose Palampur condition, the soil organic carbon is enhanced very less when we are applying only the NPK, but if you see when we are applying the NPK plus FOM, it is enhanced up to 12. So, soil organic carbon has a very good role, and whenever we are giving the FOM or other this organic manure, by this process we can enhance the soil organic carbon of the soil. There are different type of lost carbon source which have lost over the 300 of years, or maybe one is FOM, that is very much part of the organic farming. Most of the inorganic farming we are applying only the nitrogen NPK fertilizer, so we cannot maintain only by that inorganic fertilizer, we have to apply FOM. Similarly, straw, different type of straw, we can make different type of compost, we can make vermicompost and apply the soil. Green manure crops, lots of green manure crops is there, and in my earlier classes I have already described what is the different type of green manure crops, what is the different type of green leaf manures, and the city waste. Every time outside of the city lots of garbage is there. This city waste we can also use tremendously for our carbon source, and if we scientifically manage this carbon, this different type of carbon source in the soil, we can enhance the soil carbon content and the soil quality. This is the soil increase carbon in several other experiment we have seen. We have different type of long term experiment in India, and by the Indian Council of Agricultural Research, they have experimented over the years in long term, so that what is the soil condition change over a long period of time. And if we see increase in the soil organic carbon, how much soil organic carbon is increased when we are applying some part of FOM along with the NPK. So, base level is only FOM, but when we only NPK, but if we applying a FOM along with the nitrogen, phosphorus and potassium, how much percentage increase in the soil organic carbon. And if you see in case of some site it is increased up to 0.5, in some part it will increase 0.4, in some part the soil organic carbon constant is 0.3, in somewhere it is 0.35. So, most of the cases soil organic carbon is enhancing. In maybe some parts the area is very low, it is increasing, but the magnitude is low, but in some cases soil organic carbon is increasing. So, there is a very good role of the FOM and other organic materials to enhance the soil organic carbon over a long period of time. This is our experiment in our northeastern hill region in Meghalaya ICR Research Complex, how the soil organic carbon is enhancing under different nutrient management practices. Because in organic farming somewhere we are telling go only the vermicompost, somewhere FOM, and somewhere we are giving combination. And we are very happy to see in most of the years from 2005 to 2019, if you see our condition, the highest soil organic carbon concentration is achieved when we give a combination. 75% of the nutrient we are giving through FOM source and 25% of the nutrient we are giving through the vermicompost source. So, not only the organic manure only, which type of organic manure we have to apply, that also we have to see, so that we can maintain a very good soil organic carbon. And if the soil organic carbon concentration is enhanced to a certain level, a very good condition, after that probably every year we have not to use too much organic manure or FOM. So, in that condition after 5, 6, 7 years, it will be very easy to maintain our soil fertility and the yield level in organic farming. So, we have done a separate experiment how the soil organic carbon and different type of our available nutrients like available nitrogen, phosphorus and potassium and the soil microbial biomass carbon over changes with the addition of FOM and other organic matters. And if we see in case of our experiment, in case of our control where we are not using any soil organic matters, if we see it is increased up to 2.29% in case of FOM. So, it is also increased from the initial level. So, this soil organic carbon is not only enhancing, this has a also role for the enhancing the nutrients. If you see available nitrogen content is also enhanced from our initial level, also we are getting the available phosphorus is enhancing, all available potassium is there and also the SMBC. So, by this I want to tell, so when the soil organic carbon has a very direct correlation with the available nutrients in the soil. So, when we have increasing the soil organic carbon, it not only increasing the soil organic carbon, but it also increasing the soil available nutrient status, and that is very much needed for a better crop growth. In a separate experiment we have done what is the different type of activities on the soil organic carbon and associated with bulk density and SMBC. Not only our nutrient source has the effect, also we have the cropping system has effect. So, sometime if I want to tell mostly on the organic carbon, if we see, if you see organic, our soil organic carbon is 3.53%, while in case of inorganic that is 2.01. So, you are applying only nitrogen, phosphorus and potassium and we are not giving any type of soil organic carbon to the soil, maybe organic residue or FOM, our soil organic carbon cannot be enhanced up at a certain level. But if I are using 100% organic or we are going also integrated method by the addition of organic manure, so we can enhance the soil organic carbon. So, though in the soil organic carbon will be enhanced, lots of the soil physical, chemical and biological parameters will be enhanced, the soil health will be enhanced and the soil quality index will be enhanced, and that is very much needed under organic farming, because we have to feed a very high number of population, we have to maintain our soil, we have to maintain our ecosystem and the environment. Different technologies, we have technology how the surface runoff and soil loss has been occurred, and this is experiment has been done to know whether when we are applying different type of organic manure or in the fallow land, what is the soil loss. And if you see in some period when there is fallow land, we are not doing anything, the land is become fallow, what is the soil loss? It is more than 14.8 ton per hectare. And if you see when we are applying the FOM every day, the loss of soil is reduced only 544 kilo hectare. And also in case of green manure, it is 3.2 ton per hectare. So, these soil organic matter and soil organic materials not only enhancing the yield and other nutrient concentration, they have also enhanced the soil stability, soil aggregation, so that soil loss will be very much minimized. There are different type factors is available for the decomposition. The temperature is there, temperature helps in the microbial process, either their growth will be less or more. Our moisture is very much needed, because all these microbes work efficiently within a very moisture good level, not in very high temperature and not in the very less temperature, not under the snowy condition, they prefer some optimum moisture condition. Similarly, the pH, if you see most microbes, we have optimum activity near pH 7, fungi most active in acid soil, whilst the bacteria is moderate soil pH. So, this soil organic carbon and soil materials, they also temperate the moderator, they also moderate the moisture and also they moderate the pH, and thereby they are influencing the process of the rate of decomposition. The organic matter also released, there is a different type of reel, and generally we can tell in a, if we just 1 ton of organic carbon, 100 kilo of nitrogen, 50 kilo of phosphorus and 15 kilo of sulfur becomes available into plant, and rest of the parts is going back to the atmosphere, and there our carbon sequestration has a very prominent role. Apart from the nutrient cycling, it also helps the other cycle, not only also the nitrogen cycle, there is the phosphorus cycle and the potassium cycle, and with the helps of microbes these nutrients will be available over plant. If we already I have told there is a process of immobilization, crop residue very high CN ratio, and there may be mineralization if the CN ratio is less. Thus, we have to think how we have to organically manage our carbon, so that we can also manage the organic nitrogen, and also the availability of other nutrients will be enhanced. So, question is that our population is too high. Population is more than 700 crore, that is 7 billion. Population is increasing, our agriculture area is decreasing, human pressure, and our lots of our agricultural land is going diverted to different type of infrastructural and development activities. So, we have to manage our soil, we have to maintain our soil quality, we have to maintain our soil fertility, so that our future generation will not be hampered. We can give our soil in a very best condition to our future people, so that they can survive of this planet without deteriorating their soil health or compromising their nutrition and others. So, a society has two choices: wait until the catastrophe falls us, when we cannot do, otherwise you act to fail the catastrophe. So, it is high time from our human beings to take care of the soil, to maintain the soil organic carbon, so that our future generation will depend on the soil, they will benefit from this quality soil, and their lives living standards and their health, everything will be improved. Thank you.